Good morning, students. Today we will be demonstrating to you the experiment number 3, and this again is a titration of KMnO4 versus oxalic acid. Students, in the earlier 2 videos of a titration, we did 2 experiments, that is experiment number 1 and experiment number 2, in which the KMnO4 was titrated against ferrous ammonium sulfate. Now in this experiment number 3, it will be KMnO4 versus oxalic acid. Now students, the instruction for the practical is being written on the board along with the calculation. So first of all, I will be explaining to you the entire procedure, demonstrating to you, and then we will be showing you the calculation which is to be done in this experiment number 3. Now in this experiment number 3, you are provided with 2 solutions as follows. First is a C13 solution. C13 is a solution of 3.20 gram of potassium magnate per liter of the solution. So solution containing 3.20 of potassium magnate. This is 3.20 of potassium magnate per liter of the solution. Then C14 is a solution containing 6.30 gram of oxalic acid crystals. What is oxalic acid formula? Formula for oxalic acid is COH and then COOH and then 2 molecules of water. This is oxalic acid. Am I clear? So you are provided with 2 solutions. C13 is a solution of KMnO4. C14 is a solution of oxalic acid. KMnO4 solution is a 3.20 gram per liter and oxalic acid is 6.30 gram per liter. Now, what is the procedure for this? Rinse and fill the burette with C13 solution. So, in the burette, which solution is to be filled up? C13 solution. That is a solution of KMnO4. Then pipette out 20 or 25 ml. I will be demonstrating to you by 25 ml. Am I clear? So 25 ml of the solution, which is C14 of the oxalic acid, in a clean conical flask. I think you must be understanding it very carefully. Burette must be filled with the KMnO4 solution. 25 ml of the oxalic acid solution is to be pipetted in a conical flask. Then to this add 20 ml of dilute sulfuric acid. How will we add dilute sulfuric acid? By use of a measuring cylinder. So we will be adding dilute sulfuric acid, specially provided for the titration. This is a difference from the previous experiment. Warm the content to about 60 degrees C. After adding oxalic acid in a funnel or pipetting out oxalic acid in the funnel and then adding sulfuric acid, which is C15 in the funnel, we have to heat the content to about 60 degrees C. We can measure the temperature by using thermometer till the bubbles appear at the bottom of the flask. Am I clear, student? Now titrate the content in hot condition. Once the bubble appears at the bottom of the flask, start adding drop by drop C13 solution, that is a solution of KMnO4 from the burette till the permanent light pink color appears in the conical flask. And when the light pink color appears in the conical flask, that will indicate the end point of the titration. You have to repeat this experiment at least thrice so as to get 2 concordant reading. So that we get the 2 concordant reading over here. So repeat the above procedure to get at least 2 concordant readings. The equation for the reaction is given as KMnO4 when titrated against oxalic acid in H2SO4, pink color, this will result in the formation of potassium sulfate, manganese sulfate, water and carbon dioxide, or the ionic equation is given over here. The relative atomic mass of manganese, oxygen, hydrogen, potassium and carbon is given. After titrating this, what you need to calculate? First is the molarity of potassium magnate solution. Is it clear? Molarity of C13 is to be calculated. Then in the next one, molarity of hydrated oxalic acid solution is to be calculated. Then the molecular mass of hydrated oxalic acid is to be calculated. Then the numerical value of X is to be calculated. So in this experiment number 3, you have to show the calculations for calculation of molarity of KMnO4 solution, molarity of oxalic acid solution, molecular mass of hydrated oxalic acid solution, and the numerical value of X in this. So as I have already told you, oxalic acid formula is COH whole twice H2O. So this X value must come nearer to the 2 to have a correct answer. Now this procedure will be demonstrated to you. So now I will be demonstrating to you how to obtain the titer values. Then through calculations I will explain to you how do we calculate or solve for these 4 questions which has been asked in this titration. So now we will be demonstrating to you the titration of experiment number 3. Now student, I will demonstrate to you how to obtain the titer value in a titration of KMnO4 versus oxalic acid. Now as you all know, this is burette and marked from 0 to 50. Fine. Then this is pipette of 25 ml capacity. This is a funnel, a wire gauge. Then this is a conical flask, measuring cylinder, tripod stand, a solution of KMnO4, solution of oxalic acid, and a solution of sulfuric acid. One more thing we will be requiring, that is a thermometer, as we have to heat in this. This is a thermometer. Am I clear? So you must be familiar with all the apparatus that we will be using. Now how this titration is to be done? We will clamp the burette in a clamp stand. You can see this. Now what will I do? I will fill the burette with a KMnO4 solution. How it is to be done? You may see over here, I will put the funnel over it. Fine. Is it clear or not? Now, how am I doing this? You may see it from this side. This is a clamp stand. On the clamp stand, I have clamped the burette, and this is a KMnO4 solution will be filled into it. How will I fill the KMnO4 solution? This is through funnel, I will fill it up to the 0 mark. You may see over here. Fine. Through funnel, it is being filled up to the 0 mark. I hope you must have been able to see it. So up to 0 mark, KMnO4 solution will be filled in a burette. You may see over here. I'll just pick it up and show it to you. You may see over here. On a clamp stand, the burette is clamped. I have filled the burette with KMnO4 solution. This is a funnel over it. I am putting it over here so as to demonstrate the rest part of the experiment to you. Is it clear to you all of you students? Now I remove this funnel from here. It is being filled up to the 0 mark. Now student, we have a pipette with us. This is a pipette. For this demonstration, I have taken the 25 ml capacity pipette. When you come to the lab for performing the experiment, either it will be 25 ml or 20 ml pipette will be provided to you. That will be told to you before the experiment. Now, this is oxalic acid solution. You can see over here, it is a solution of oxalic acid. And this is a conical flask. We will be introducing the 25 ml of oxalic acid into conical flask through pipette. As you know, what is being done in the pipette? The solution is to be sucked, and then it is to be this. You must ensure that the solution shall not settle down. Then now I will pipette out the oxalic acid. All of us know how to pipette. On pipette, there is a etched mark, circular mark. Up to this capacity, it is to be filled. So, it is how? It is to be pipette. You can see up to the etched mark, I have filled this pipette with the oxalic acid. Now this is to be introduced into this conical flask. So remove this thumb or finger from the top and it will be inserted in the conical flask. You can see this. So I think this must be very clear. What we have done, we have filled the pipette with the burette with the KMnO4 solution. KMnO4 is a C13 solution, and then introduced or pipette 25 ml of oxalic acid solution into this. This is oxalic acid solution. Now to this, as per the instruction given, we have to add 20 ml of dilute sulfuric acid. This is a measuring cylinder. This is 20 ml over here. And this is a dilute sulfuric acid, which is C15. I'll add dilute sulfuric acid into this up to 20 ml. So through measuring cylinder, 20 ml of dilute sulfuric acid is to be added into the flask. Is it getting clear? So 25 ml of dilute sulfuric acid is added into the oxalic acid. Fine, 20 ml of dilute sulfuric acid is added into the oxalic acid. So 25 ml of oxalic acid we have taken, and to this we have added 20 ml of a dilute sulfuric acid. Now what is to be done? As instructed to you, this solution is to be heated nearly up to a 60 degrees C till the first bubbles appear at the bottom of the flask. That means we have to heat it up. After heating it up, once the first bubble appears at the bottom of this, then we'll start adding the KMnO4 solution. We'll add the KMnO4 solution till the persistent pink color is obtained. So I'll just heat it. For heating, what is required? We need to heat. So we need a tripod stand for this purpose over here. We'll put, this is a burner. A burner is being put over here. And now we will put a tripod stand over it. You can see it over here, this way. The tripod stand will be put on this. Am I clear? We will now lit up this one over here. So we will lit up this and then put a wire gauge over it. You may see over here, this is being lit up. Now over here we have put a wire gauge. You can see, student, over here. Now above this, I will be putting the solution is to be put on this, and then I will start the titration work. So this is being put over it, and inside this we will put a thermometer. We will heat it up to 60 degrees C. And how do we come to know to what temperature it is to be heated? I must ensure that heating must be done till the first bubble appear at the bottom of this. Is it getting clear, student? Till the first bubble appear at the bottom of this. You may see over here, I am heating this. I will be observing the temperature in the thermometer. And we will be heating it approximately up to 60 degrees C. So we will be heating it till the temperature rises to about 60 degrees C. Am I getting clear, student? Once it gets heated to 60 degrees C, then we will stop heating it. Will heat till the first bubble appear, and that will be approximately to the temperature of 60 degrees C. So we are heating it up. So hopefully you must have been understanding. So now student, this you can see over here, the first bubble appears at the bottom of this, and this gets heated up to the temperature of about 60 degrees C. Is it clear? Now, we will start the titration work. When it is hot, we will start adding the KMnO4 solution into this beaker over here. So, KMnO4 solution is to be added into this. We will just adjust this to the level so that we can easily observe, and in the drop-wise manner, we will add KMnO4 solution till the persistent pink color is obtained. You see over here. Now we have started added KMnO4 solution into this in a drop-wise manner. I think the demonstration must be very, very clear to you. And we'll add to obtain the persistent light pink color. The solution in the conical flask must be constantly shaken till the persistent light pink color is observed. You can see over here, KMnO4 solution is being added into the oxalic acid, which is being heated to the 60 degrees C, and as soon as the light persistent pink color is observed, that will indicate the end point of the titration. You may see over here, student. It is indicating the titration of oxalic acid with the KMnO4 solution. I am adding in a drop-wise manner the KMnO4 solution to oxalic acid, and we'll see when the light persistent pink color is obtained. You can still see I am adding it, and still the persistent pink color is not obtained. I will continue adding it in the drop-wise manner till I obtain the titer value. You must remember, although I will be demonstrating to you with only one titer value, but you have to conduct the same procedure at least thrice till you obtain the two concordant reading. Concordant reading means a common reading over here. The see over here, I have reached up to 19, but no pink color is yet obtained. So I am continuing adding the KMnO4 solution into this till I obtained the persistent light pink color. It is nearer to coming over here. As you must have been seeing over here, slightly and slightly pink color has started coming, but when I shake, it gets disappeared. So I'll again add few more drops of a KMnO4 solution, and very light persistent pink color will be obtained. You may see over here, still few more drops are required. We are almost there, so I'll add few more drops to obtain the persistent light pink color of the solution. You may see, although it seems to be getting pink, but when I shake, it still disappears. So few more drops. There will be the addition of few more drops of a KMnO4 solution. And as soon as I obtained the persistent light pink color, it will indicate the end point of the titration. Is it getting clear, student? We are almost there. Few more drops and we'll get the persistent light pink color. You may see students over here. This is a light pink color. So almost a light pink color is obtained over here. Can you see this? One or two more drops. And it will be a persistent light pink color. You can see over here, a light pink color is obtained, which is not disappearing now. This indicates the end point of the titration. And over here, the titer value comes to be, in this titration, it comes to be 24.4. Am I clear? Now students, after obtaining the titer value, I'll show to you how to obtain the result by calculations. Now, in this case, now I need to do the calculations. How will I do the calculations? What was the first point? I have to calculate the molarity of KMnO4 solution. Now, as per the instruction of the board, all the calculations are to be done up to 4 decimal place. So, first of all, we'll make the observation table. This is serial number. Volume of oxalic acid, that was the size of the pipette, 25 ml, 25 ml and 25 ml. Then the burette reading, initial value in every case is 0. Final value in the first titration will be 24.4, then again 24.4 and then 24.3. Am I clear? The volume of KMnO4 solution used will be this minus this value. So it will be 24.4, 24.4 and 24.3. Then what is the titer value? Which are the two common values over here? 24.4. So titer value in this case will be 24.4 milliliter. Am I clear, student? So what is the capacity of the pipette used? Capacity of the pipette used will be 25 ml over here. So capacity of pipette used will be 25 ml. What is the titer value in this case? It again comes to be equal to 24.4 ml. Now we will be calculating. What was the first question which was to be calculated? We have to find out the molarity of KMnO4 solution. Molarity will be strength upon molecular weight. What is the strength of KMnO4 question given? It is given in the question. Strength of KMnO4 is 3.20 divided by 158. It will come out to be equal to 0.02025 molar. So first question is clear. You have to indicate the capacity of pipette. Here in this titration experimentation, I have used 25 ml. What will be the titer value? 24.4 ml. But when you come to the lab, the size of the pipette given will be 20 ml to you. Molarity is strength upon molecular weight. What is the strength? 3.20 upon 158. So titer value will be 0.02025. This must be reported at least up to 4 decimal place along with the unit to score a marks in the board examination. Am I clear, student? Now look at the second question. What we have to find out is molarity of hydrated oxalic acid solution, which is C14. So formula will be M1V1 of KMnO4 to M2V2 of oxalic acid equal to N1 upon N2. As seen in the equation, 2 mole of KMnO4 are neutralized by 5 mole of our oxalic acid. The balanced equations are given as I have seen you earlier in the earlier part of this video. Now putting off all the values, what is the titer value of KMnO4? 0.02025. What is V1? V1 is titer value. Molarity was this, titer value 24.4. Molarity of oxalic acid is to be determined M2. What is the volume of oxalic acid taken? 25 ml. This will be equal to 2 upon 5. If you solve it up, it will come out to be equal to 0.04941 molar, at least up to 4 decimal place. Now the third part is we have to find out the molecular mass of our oxalic acid. Molecular mass of oxalic acid will be strength of oxalic acid upon molarity. What is the strength? It is given in the question. For the strength of oxalic acid is 6.30 gram per liter. And what is the molarity of oxalic acid obtained? 0.04941. Am I clear? On solving it out, it will come out to be equal to 127.504. Am I getting clear or not, student? So 3 questions are solved. First was the molarity of KMnO4, second was molarity of oxalic acid, and third is the molecular mass of oxalic acid. Even if we experimentally calculate the molecular mass of oxalic acid, it is 126. So it is coming nearer to that. Now in the next part, what we have to do? We have to find out the numerical value of X. Oxalic acid formula is H2C2O4 XH2O as given in the question. The molecular mass comes to be equal to 127.504. We have to find out the value of X. Putting all the masses, mass of hydrogen will be 2, carbon 2 into 12, 24, oxygen 4 into 16, 64. Water 18 into X will be equal to 127.504. If you solve for this, the value of X in this case will come to be equal to 2.03, which is approximately equal to 2, and which is the right answer, because the formula for oxalic acid is, what was the formula for oxalic acid? COH and then COH and then 2 molecule of water. So what is the value of X coming over here? 2. So this is how the calculations of 4 questions given in the titration is being done. That is the molarity of KMnO4, molarity of oxalic acid solution, molecular mass of oxalic acid, and the numerical value of X. So this was experiment number 3, that is the titration of KMnO4 versus oxalic acid, and the 4 questions we have done. There can be one more type of a calculation which can be done with this experimentation, that will be done in the experiment number 4 with you. So I think the first 3 experiments are clear. First was KMnO4 versus ferrous ammonium sulfate, the different calculation in the experiment number 2. Now in experiment number 3 we have done KMnO4 versus oxalic acid. In experiment 4, that is the next titration, we will be doing the same procedure but with the different calculations. Till then, thank you.